All right, welcome back to the last section of the day. So now we're on to 4.2, all about the mean value theorem. So last section we talked about how extrema exist at C, therefore f prime of C will equal 0. So if we look at the graph that I have already drawn, we see that point A and point B, I can draw a line and show that f of A equals f of b. Well, what does that mean about f of a and f of b, or the numbers in between them? So we can see that the slope is 0, right? Because it's a horizontal line. We know that it has a slope of 0. Well then, what about, I see up here I have a local min-max, and I know that has to have a instantaneous rate of change, instant derivative that equals zeros. Ooh, sorry, stumbling over my words. So this yields a really cool theorem called Rolle's theorem. All right, and it says that if we suppose f of x is continuous over the closed interval AB and differentiable at every point in the open interval AB, if f of A equals f of B, meaning the slope between them is equal to 0, then there exists a point C in that interval such that f prime of C equals 0. So in this case, our picture above, this guy would be C. Alrighty, really cool theorem. So it actually has more applications than you think, other than, oh, if f of A equals f of B, then there should be at least one point between them. So if we call f of x equal to x cubed plus 3x plus 1, then we can use Rolle's theorem and the intermediate value theorem to tell us about how many roots are in between, or how many solutions, I guess, because if this is equal to 0. So we're going to show that f of x has exactly one root. So using the intermediate value theorem from last chapter, f of -1 is going to equal what? -1 plus 3x minus times -1 plus 1, so that is -3, and then f at 1 or not even f of 1, f at 0 will equal 1. So we know there exists at least one, but we want to show that there's exactly one. And that's where Rolle's theorem comes in. So I can show that if the derivative never equals 0, then there's no other value for f of a to equal f of b, right? So if we find f prime of x, we know that is going to be 3x plus 3 . That actually never equals 0, does it? Because, whoopsies, oh, 3x squared. Because we set this equal to 0, we factor out a 3, so we get x squared plus 1 equals 0. So x squared plus 1 equals 0. So x squared equals -1. Not cool, does not exist. Not a real number, right? That would give us an imaginary number. So f prime of x never equals 0. Well, that tells us that no other point can equal the same function value, right? So using Rolle's theorem, since f prime of x does not equal 0, there does not equal c such that f of c equals 0, right? So basically what this is saying is no other point can be a root. We're only going to have one. So intermediate value theorem tells me I have a root, I have at least one. Rolle's theorem says, well, the derivative can't equal 0, so there's not going to be ever a time where I'm going to equal that function value again. So this will make, if this seems kind of confusing right now, as we continue on, this will be a little easier to explain. So what we're kind of looking at is a graph that looks a little like this. So here's our root between -1 and 0. But since there's no time where f prime of x equals 0, I'm not going to have any other root. Alrighty, so now there's like another version of Rolle's theorem, kind of like a slanted version. All right, so if I kind of draw a little picture, and I have this curve, well, we can see that from A all the way up here will be like that, and then there's going to be some point whose instantaneous rate of change is equal to the average rate of change over that interval. And that's what we kind of mean by slanted version of Rolle's. Rolle's is horizontal tangent, and now we have like a slanted tangent. Alrighty, so this is called the mean value theorem. Remember, the mean is just another word for average. So this has to do with the average rate of change. So we're going to suppose, again, that f of x is continuous on the closed interval a, b, and differentiable on the open interval. All right. Then there exists at least one point C such that the slope between f of b minus f of a over b over a, so the slope between a and b, is equal to the derivative at that c. All right, so this chunk right here is the average rate of change over the interval. And this is the instantaneous rate of change. So the IROC of some point in said closed interval. Alrighty. So let's do an example, kind of similar to one we did earlier. So we're going to let f of x equal to x squared on 0 to 2. Alrighty? So we're going to find that point C such that the average rate of change over 0 and 2 equals the derivative at that point. Alright? So f prime of x is going to equal 2x. We know that from power rule. So we also know that f of 0 is 0 and f of 2 is 4. So f of b minus f of a, b minus a, that's going to be 4 minus 0 over 2 minus 0. So that's going to equal 4 over 2, which is just 2. So when I want to find when 2 equals f prime of c, which we know is 2c. All right, 1 second. Alrighty, we're back. My pen died, so I had to charge it. My apologies. So we were going through this problem, and we were looking at f of x equal to x squared on the closed interval 0 to 2. And so we took the derivative so that we had f prime of x, and then we also found the endpoints. We plugged in 0 and 2, so we got 0, 0, and 2, 4, and then we found the slope between those 2 points. That gave us 2. So then we set that equal to our derivative at some point c. Now we're going to divide both sides by 2, and I'll get that 1 equals c. So that means that when x equals 1, the slope f of 1, f prime of 1, will equal 2, which is the average rate of change over the interval. cool, right? So this also has some really cool physical interpretations as well. So let's do another example. And let's say if a car goes 352 feet in 8 seconds, starting at a complete stop, well then we can see that the average velocity over our time interval, which is 0 to 8. Right, so at 8 seconds, we're going to be 352 feet away. And since we're starting at a complete stop, at time 0, we're going to be at distance 0. So that average velocity, we'll call it v sub a, is going to be, what is it, 352 minus 0 over 8 over 0. Sorry, 8 minus 0, which is 8. And that simplifies to 44 feet per second, right? So that would mean that by the mean value theorem, there will be a specific time which the car is traveling exactly 44 feet per second, which is also 30 miles per hour. All right, so if you tell me I was here at this time and I was there at this time, and you said you weren't speeding, then I can use the mean value theorem to show that you were speeding. So if it was 25 miles per hour and this says the average was 30 miles per hour, well then at some point in the middle of that you had to be going 30 miles per hour. All right, so there's some consequences from the mean value theorem, some other things that kind of just like fall out, some assumptions we can make. We call these corollaries. They're like little baby theorems. So if f prime of x equals 0 for all x in AB, then f of x equals some constant c. Basically, if the derivative always equals 0, Rolle's theorem says that then there has to be 2 points equal each other. Well, then if the derivative is always 0, all those points are going to equal each other. We can just call it some constant. All right, it's just going to be some continuous horizontal line. All right, and then we also get this other corollary. That states that if f prime of x equals g prime of x for all x in AB, right, in that interval, then there exists a constant that we might also just call C, such that f of x equals g of x plus c for all x in that interval. Right, so if your derivative equals the same, that means you're just separated by a constant. You're kind of just shifted up, right? So let's look at f of x equal to x squared. Right, so that's just going to be right here. 1, 2, 4. Something like, oopsies. Something like that, right? That's what f of x equals. Well then, what if I call g of x, x squared plus 1? Well, then that's just going to be and then we had h of x, x squared minus 1. They're all the same overall function, whoopsies, but we're just shifting a little bit. But you can see if I take the derivative, that constant, it's derivative 0, so I'm going to get the same derivative. All right. Coolio. So now let's do one little example on the mean value theorem from your textbook. So this is going to be 4.2.7. And you're asked to find the value or values of C that satisfy the mean value theorem. All right, and we're given that f of x equals x cubed minus x squared, and our interval is from -1 to 2. Perfect. So now we can plug in our endpoints and find the average rate of change over the interval. So we're going to plug in -1, so I'll get -1 minus 1, so it's -2. And then I'll get 8 minus 4, which is 4. So I have that f of b minus f of a over b minus a equals 4 minus -2, so that's 4 plus 2. And then 2 minus a -1, so that's 2 plus 1. So that's 6 over 3, and we get 2. Again, weird. Okay. Right, and then we want to find f prime of c. So every time there's an x, I'm just going to put a c. So then I'm going to have 3c squared minus 2c. And I know that has to equal 2 by the mean value theorem. Alrighty. So, oops, that is not supposed to be an x, that's supposed to be a c. Alright, so now what I'm going to do is I'm going to move this 2 over, so subtract 2 on both sides, and I have that all equals 0. Now, I don't know how to factor this. I really hate when things are in front of my c squared, so I like to use the quadratic formula. So that's going to mean that c equals -b, so positive 2 plus or minus the square root of b squared, 4 minus 4ac, all over 2a, so 3 times 2 is 6. So then 2 plus or minus 4 times 3 is 12 times negative 2 is 24 plus 4, because that's a negative, is 28, all divided by 6. 28 is 4 times 7. So the square root of that is going to be the square root of 4 times the square root of 7, which equals 2 square root of 7. So this is going to be 2 plus or minus 2 root 7 over 6, and that simplifies to 1 plus or minus square root of 7 over 3. So if you put those in your calculator, remember we need numbers that are in between negative 1 and 2. So we get that, we'll call that one C1. C1 equals 1 plus the square root of 7 over 3, which is about 1.22. And then we'll call C2 1 minus the square root of 7 over 3, and that's about negative 0.549. Both of those numbers are in between. So these two values satisfy the mean value theorem on negative 1 to 2. Alright, so you guys have homework on this due, what is this, Thursday? So Wednesday? Alright, so I will see you guys next week. Goodbye.